All right, so over here we have our computation model created in Excel about like for our projectile that we are kicking at some sort of velocity as like, let's say 30 meters per second and some sort of theta, which is 60 degrees. Okay, so for the test case A, we are not taking into account the wind and the air drag in this case. So we are going to have these sort of projectile path for our test case A, and the energy versus time graphs. And for test case B, we have to say we are told that we have to drop the ball from initial height, some sort of initial height, and so over here we are dropping the ball, but like we have to write down like some sort of initial velocity, like only a little bit, because so we don't interact with division by zero errors. And 90, and right here we are taking into account the air drag. All right, so once we're done changing, see the graph changes significantly because we are just dropping the ball, and the x distance is in negative 23, 10 to the negative 23, which is basically zero. So the ball is dropping straight downward. For let's just case for test case C, let's just change it back to our normal height and speed over here. Okay, so for the test case C, we are to take into account the air drag over here. So right here we can see the projectiles, like test case A is different and test case C is different right here because of the air drag. It repulses moment, so like it opposes the speed of the ball, and it will end up like it will end up dropping, like it will end up dropping less than like over here it is dropping at 80 meters, so over here it will drop around like around 35 meters. So it just change in horizontal distance. For test case D, we are to say that we have said that we have to include some wind speed. So including wind in the direction of the motion, it will increase the horizontal distance, which is shown in the graph over here. And finally for the test case E, we are to say that it also opposes, the wind opposes the movement of the ball. I mean the direction of the ball. So we are going to put negative 10. So basically, as we can clearly say, is that it is moving like backward like this because at the first place air drag is acting on it, and so once the ball is taking the flight, air drag is stopping it, and as well as over here we are saying the wind is in the opposite direction of the flight. So basically also wind and air drag both will oppose in the same direction. So it will so the ball's flight will move like this, as we have as we can see in the graph right here, and it will also affect the work done by non-conservative forces, because we are taking two non-conservative forces over here. So it will increase as the time increases, as you can see over here, the green curve.